and my topic is cascaded amplifiers. Towards the left of the screen, I have myself. What is a cascaded amplifier? Cascaded amplifier is a two-port network comprised of a series of amplifiers in which each amplifier connects its output to the input of the next amplifier in the chain. At the top, I have two-stage cascaded amplifier, a block diagram, and at the bottom of the screen I have the circuit implementation of this two-stage amplifier. There are three types of cascaded amplifier. One of them is RC coupling that provides an acceptable frequency response with affordable cost for implementation. The second, we have transformer coupling, and it expands its signal across the primary transformer winding performs as a load. Using this method can be costly because of the wide frequency response transformer. And lastly, we have direct coupling. This permits the signal with zero frequency, meaning that the direct current to be passed around from the input to the output. And we have the circuit implementation of these three different cascaded amplifier types towards my left on my screen. The purpose of cascaded amplifiers. It helps to increase an amplifier output to meet a specific requirement. For instance, to increase the signal strength in a television or radio receiver. Amplifier can provide your design with a higher current gain or voltage gain. In many instances, it is used to achieve a necessary input or output impedance. I have picked an example of a three-stage amplifier, and the question asking to find the voltage gain and the current gain and also the power gain of this three-stage amplifier. And there is a given three-stage amplifier figure in this question, and using these given formulas, I will be solving this. Here's a solution of my problem that I picked based on three-stage cascaded amplifier. At first, the source signal appearing in the input terminals of the amplifier is obtained using the voltage divider rule, which gives me 0.909 voltage. And the voltage gain of the first stage is obtained by a V1 VI2 divided by VI1, and this gives me 9.9 volts. Similarly, the voltage gain of the second stage is also obtained by considering the input resistance of the third stage to be the load of the second stage, and this gives me a V2 equal to VIO3 divided by VIO2, and this gives me 90.9 volts. And finally, the voltage gain of the output stage as it follows: a V of 3 equal to VL over divided by VI of 3, and this gives me 0.909 volt. So the total gain of the three stages in cascaded now can be found from A V equal to VL divided by VI of 1, and that gives me 818 volts. To find the voltage gain from the source load, we multiply by A of B by the factor representing the loss of a gain at the input, and that is 743.6 volts. The current gain is found as follows: AI is equal I of 0 divided by I of I, which gives me 8.818 ampere or 138.3 dB. The power gain is also found by A of P, PL divided by P of I, which gives me 66.9 watts. And that's how typically we find the voltage gain, the current gain, and the power gain of a 3-stage cascaded amplifiers. Here are my resources that I use to find the information that I provided on these slides. And thank you very much for listening.